This week we're going to be focusing a lot on something that plants and humans actually have in common, and that's nutrition. Similar to humans, if we eat a really balanced diet, we might get all of the nutrients that we need. If we don't, then we might have to take vitamins in order to remain healthy and strong and carry on all the different functions and process that our bodies need to do. And plants are pretty similar. Plant nutrition just means the availability of different elements. Plants need certain elements from the periodic table, if you remember from your science classes, in order to survive. Just like we need vitamin A and calcium, plants also need different minerals and elements, so calcium being one that we share. Similar to taking vitamins, if plants don't get those kind of nutrients to the soil, then they would need to also be given a vitamin, and that's where fertilization comes in. I hate the term fertilization because, as we learned in week 5 and 6, actual fertilization has to do with sexual reproduction. But for some reason, we've chosen to use the term fertilizer to basically mean plant vitamins. So, again, take into account plant anatomy as we go through the week. We've learned that plants must absorb water through their roots, and so those nutrients need to be taken up through the xylem and carried out through the plant. And so that those nutrients need to be in a solution in order for plants to absorb them. And different factors can contribute to how well plants are able to absorb those nutrients. For example, pH. If pH is very high and alkaline, or very low and acidic, certain nutrients aren't as available as when it's closer to neutral, or actually a little more acidic, around 6.5 on the pH scale. There's a couple of different sources for nutrients that we'll talk about. A lot of them are supplied naturally for plants in the soils, either through the breaking down of rocks and minerals, for example, for our phosphates or potassium, or through the air, through the fixation of things like nitrogen. In an artificial environment, so in the greenhouse or a nursery, they might get those nutrients in the soil if you're using compost or organic material, but chances are they need to be supplied externally through either mixing in some kind of solid fertilizer or watering through the irrigation. There are several different categories of nutrients we're going to be talking about, but there's 16 elements. And if you remember the periodic table on the wall from your science classrooms, you're going to find a lot of these are familiar. The 3 elements that plants use all the time, and thankfully are naturally abundant through water and air, are carbon, hydrogen, and oxygen. They use hydrogen and oxygen, the water that they take up through their roots they use in photosynthesis, as well as the carbon to fix in the carbon fixation process in the second part of photosynthesis. Fortunately, those elements are not very limited in their organic elements that they're going to find in the air and water around them. But there are macronutrients. In fact, 3 primary macronutrients and 3 secondary macronutrients that we consider macronutrients because plants need a lot of them. And there are also a lot of little amounts of elements of nutrients that plants need as well. So we're going to be learning about that this week. The ones that are required in large amounts are listed here. We'll be talking about those next. And they do different things for plants. And then the secondary macronutrients are still needed in large amounts, but not quite the same as the N and the P and the K. And we'll talk a little bit about in fertilizers how that looks. But the primary macronutrients, the secondary macronutrients needed in larger amounts, and the micronutrients are listed here that plants need in smaller amounts. So we'll talk a little bit about the role of nutrients, and we'll also look at how we can determine if plants are deficient in particular nutrients. For example, symptoms like the discoloration or chlorosis of leaves, or actual death or senescence of leaf tissue, stunted growth, other examples of nutrient deficiencies you may have observed in your own house plants or plants that you've grown, or perhaps plants out in nature. So we'll take a look at how to recognize these symptoms. Many plants have yellow leaves for a variety of different biotic and abiotic conditions, including nutrient deficiencies. So we'll learn a little bit about where to look precisely on a plant to help recognize these different deficiencies this week. We'll also learn, just like vitamins in humans, a little bit about how to add nutrients to plants through fertilizers. We'll take a look at dry applications as well as liquid applications of fertilizers, and how that we can use those to address nutrient deficiencies in plants. finally this week, we'll also take a look at how to calculate the right amount of fertilizer, because just as there can be too much of a good thing, for humans, you can also have too much of fertilizer. So we'll take a look at how to appropriately calculate. For this week, we'll be looking at nutrient stock, nutrient solution, a stock solution that might be used in a greenhouse in fertigation. And we'll continue to talk about fertilizers as we look at different applications such as turf grass or trees throughout the next few weeks.